Thank you for coming to the second in the series in our climate science series this spring. Tonight's presentation is around the warming of the Gulf of Maine. And I am more than thrilled to introduce Dr. Kathy Mills from the Gulf of Maine Research Institute, who is going to be sharing some slides and her expertise with us this evening. So with that, Dr. Mills, I'll let you take it away. And if you have questions as we're going along, if you would just put those in the chat, and I will man the chat while the presentation's going on. And just so you're aware, Dr. Mills is on her phone because her internet's a little stable. So but you're all very familiar with that. So with that said, Dr. Mills, it's all yours.
All right. Well, thank you for those that are joining us live. And I do hope the internet holds out for this. Of course, we get a day when my Wi-Fi is not happy with the house, but Sherry's going to help me out with slides if we need to. So I'm going to start sharing my screen and let's see. Okay, all good on the slides? Okay. Well, I am going to be talking with you today a bit about some of the changes that we're seeing in the Gulf of Maine in terms of warming and what that means, particularly for fish and invertebrate populations in the Gulf of Maine. Then also have a little bit of a discussion of some extensions and implications of that. But I'm, as Sherry said, please stop me along the way if you'd like to dive in further anywhere or have any questions. And I look forward to the discussion at the end. So I am a scientist at the Gulf of Maine Research Institute. I'm a fisheries ecologist by training, but my work really tries to put together connections between changes in the ocean, the physical system, what that means for fish populations, and then also for fisheries in the region, and particularly how fisheries can prepare for and adapt to some of the changes we expect in the future. So just to give you a little bit of my background, tonight I'm going to focus on the first couple parts of that. I'll be talking about some of the changes that we are experiencing on the Northeast Shelf, particularly related to temperature, and then some of the impacts that we're seeing in marine species in the region. So when I talk about the Northeast Shelf, just to provide an orientation, what I'm really speaking about is this region of the ocean that extends from the Gulf of Maine. So we sit right here. The Gulf of Maine would be this body of water that's sort of enclosed underwater by Georges Bank. And the Northeast Shelf extends down to Cape Hatteras in North Carolina. So this is a region that we kind of think of as a holistic unit of the ocean. And on the Northeast Shelf, we have been experiencing quite rapid warming over the past 3 decades since sea surface temperatures started becoming available via satellite back in 1982. So since that time, the Northeast Shelf region has been warming about 3 times faster than the global average warming experienced in other regions of the ocean. In particular, that warming trend has been enhanced in the past 10 to 15 years. From 2006 to 2020, we would have been warming about 5 times faster than the global average. And this time period is relevant particularly to species that, have lifespans that are about the same time range, and really poses a lot of implications for how different components of the ecosystem function and how interactions between those species are maintained. So just to put this into a global context and help you understand the warming we're experiencing here in a bit of a different way, what's showing up in yellows here are regions of the world's oceans that are warming faster than 95% of the other pixels of ocean on the map. So you can see here we are, this is Florida. Here we are right here with the Northeast Shelf. And you can see that we're right in this bright yellow zone that extends throughout the North Atlantic and the Arctic. And I'll come back to this because our future projections also look quite similar to this. So this gives you a sense of which portions of the ocean are really warming exceptionally rapidly. In addition to the strong warming trend, we are also seeing changes in temperature seasonality. So when things warm up and when they cool down. And in a sense, if you think about that length of time between warming and cooling, if we define that as what feels like summer, the length of summer has been expanding in this region, again, going back to 1982, particularly in the Gulf of Maine, which jumps out here with these dark oranges and these bright reds. So in the Gulf of Maine, we've been gaining about 2 days of summer per year since 1982. And again, this is defined in temperature space, not by calendar days. And then the lengthening of summer has been not as strong in the mid-Atlantic, but it still has been increasing by about half a day per year over that same time span. And we've also been experiencing extreme heat events. So essentially what we call marine heat waves that are analogous to heat waves on land. This map shows the sea surface temperature anomalies associated with a heat wave that we experienced in the Northwest Atlantic in 2012. And during this event in 2012, we saw temperatures from Cape Hatteras all the way over to Iceland up into the Labrador Sea, running in the summer 2 to 3 degrees warmer than the long-term average. And so this created a series of events that had major ramifications, particularly felt here in our lobster fishery. And then also in other fisheries, we saw new fisheries arise during that summer for species that typically aren't found in the Gulf of Maine. And the pattern of heat waves has been actually increasing since 2012. So 2012 was our first experience with a major marine heat wave in this region, but we've had repeat events in 2016, 2018, as well as 2020. And this just gives you a sense of what that looks like. The black bars here indicate when we would consider ourselves in heat wave status, which has a specific statistical definition where we are above the 95th percentile of long-term temperatures observed on a given day for at least 5 days straight. So these would be time periods when we would define a heat wave. And you can see in 2012 that extended throughout most of the year. In 2016, we saw this occur early in the year and then summer into the fall, and in 2018 and 2020 more concentrated in the summer and fall periods. So what's causing these changes? There are a couple of major drivers of the warming that we're experiencing. One is just atmospheric warming in general. So as temperatures around the world become warmer, the oceans are absorbing that heat. So in fact, oceans have absorbed, sorry, that's misspelled, have absorbed, not observed, more than 90% of the excess heat we have been generating into the atmosphere over the past 40, 50 years. But it's also due to changes in ocean circulation that are related to climate change as well. So as the circulation system in the Atlantic changes, it's actually causing the Gulf Stream to have a stronger influence along the Northeast Shelf and into the Gulf of Maine. So in our region, our ocean waters are really controlled by two current systems, the Gulf Stream, which brings warm water up from the south, and the Labrador Current, which brings cold water down from the Labrador Sea. And in recent years, what we're experiencing is that the Gulf Stream is pushing closer to shore and further into this region, and essentially pushing keeping the Labrador Current from having a strong an influence. And so the Gulf Stream is dominating this coupled current system and resulting in warming all along this region from the Scotian Shelf down to the southern part of the Mid-Atlantic Bight. And as a result of the warming we're experiencing, we're also seeing other changes in our ocean. One is increased stratification, which means that the temperatures between the top and bottom layers of the water column are more different from each other and don't mix with each other. So we want the cool water from the deeper layers to be mixing to the surface because that brings nutrients into the surface waters that receive the light. And so obviously you need light and nutrients to have phytoplankton grow and to really start the cycle of productivity in our oceans. And warming is also associated with declines in oxygen concentrations. As water gets warmer, it holds less oxygen, and this obviously has ramifications for many species that need oxygen to survive. So these impacts come through the marine ecosystem in a variety of different ways. And as a fisheries ecologist, I am sharing with you my strong bias toward fish and marine invertebrates. I'm not really talking about plankton and lower trophic levels in some of the examples I'll be giving today, but those are certainly feeling similar effects as well. So these changes can percolate through populations in terms of where they're located, their spatial as well as their temporal distributions, how productive they are. Certain species do well under different environmental conditions and less well under others. And then as you see changes in individual species, we're also seeing changes and can expect changes in interactions between those species, particularly predator-prey linkages, as well as potentially, competitive interactions for habitat or space or other resources. And then one other effect that is important to fisheries in the region is related to disease and pathogens, whether those diseases affect the species themselves or pathogens that could pose risk to human health if that seafood is consumed. So just to walk through a few of these, I'm going to tell you a bit about a couple of those impacts in greater depth. So one of the most common changes that we see across many different regions of the ocean around the world and also on land, that we see species moving to track their preferred temperatures, which means as our ocean waters warm, many of the species are moving poleward to keep tracking the temperatures as one region warms, they're moving into a region that used to be cooler, but has now warmed up. They're also moving, or the spatial distributions are shifting to deeper depths because there's cooler water at depth as well. And I imply that a lot of this is sort of intentional tracking. In some cases, that is true. And in other cases, it's a reflection of temperature effects on the population as a whole and how productive a population might be under certain conditions. And I'll give you an example in just a minute related to lobster, where it can depth. So as a result of shifting spatial distributions, we also now are seeing a lot of species that would historically have been associated with the mid-Atlantic coming into the Gulf of Maine. A few examples here are black sea bass. So this is a benthic fish species, lives on the bottom, and has historically been found south of Cape Cod. We are now having winter temperatures in the Gulf of Maine stay above critical thresholds so that black sea bass can now sort of occupy the Gulf of Maine as a habitat that they prefer. They do migrate. Many of them migrate to the shelf break during the winter, but they come back here. This is sort of becoming more occupied routinely as one of their habitat spaces. And lobstermen are seeing these pretty frequently in their lobster traps. So they have really moved into the sort of core Gulf of Maine coastline. Squid is another example. This map shows where the Federal Fisheries Trawl Survey has typically found squid, and this reflects catches during 2001 through 2005. You can see that they're really concentrated in the mid-Atlantic and out on Georges Bank, a bit into Massachusetts. In 2012, when we had the heat wave that I mentioned earlier, squid moved into the Gulf of Maine, and they may be here in most summers, but they're quite ephemeral. So they are seen, but they don't usually come in and stick around and stay for long periods of time. In 2012, they did, and they actually kind of moved into the coastal waters, and people were seeing them there for a long enough period of time that there was a small fishery that developed to catch squid just during the course of that summer. And we also get phone calls about many other species at GMRI. People find interesting observations and call to learn more about what it is and why it's here. Seahorses and many other small tropical fish are things that we frequently hear about during the summers. So in addition to changes in spatial distributions, warming is also affecting the productivity of a number of species in the region. So some examples are related to Gulf of Maine cod. For this population, we've seen declines in for that stock as waters have warmed, particularly related to their recruitment. So they're not producing new cod as efficiently as they would have in the past. And they're also not growing as well or as quickly as they did in the past. Northern shrimps, another species for which we've seen major declines in the Gulf of Maine. This used to be an important winter fishery for, lobstermen who maybe weren't catching lobster in the winter, or ground fishermen who could target shrimp during a portion of the year. And since 2012, they actually haven't been here in harvestable numbers. They're no longer able to reproduce here in our winter temperatures that we're experiencing now. And lobster is a really interesting story of contrast. So in southern New England, which is a warmer region of the ocean to start with, the lobster population has declined substantially. While in the Gulf of Maine, we've warmed up into really an ideal zone for supporting lobsters. And this next figure, or I'll give you a figure that shows that in a bit more detail. But lobster is obviously very important in Maine and in the Northeast in general. It supported the most valuable single species fishery in the US going back to 2014. In Maine, the harvests typically run over $400 million per year in landed value and about $600 million across the range of the species in the US. So the interesting contrast arises in the Gulf of Maine experience versus the southern New England experience. So this shows temperatures in the blue line increasing in the Gulf of Maine. And as they increase here, you see this reflects landings, but the population patterns look very similar, increasing with those temperatures. In contrast, in southern New England, temperatures move sort of beyond a threshold where lobsters could reproduce at the same level. So their reproductive capacity really slowed down, and the survival through those early life stages really slowed down as temperatures moved past that threshold. So we've seen substantial declines in southern New England with warming that's been experienced in that region. We've done some much more extensive modeling of the lobster population where we can really isolate the temperature effect from other potential effects. And so we know that most of this change is related to temperature, but another really interesting thing in Maine is that the boost that the population gained from temperature was further enhanced by some longstanding conservation measures that the industry put in place over a century ago, actually. They started protecting female lobsters and large lobsters so that they could sort of contribute to the next generation of the population. And those measures further enhanced the boost that the Gulf of Maine population has been experiencing in the past, decade, 15 years or so. And so I think this is a really interesting story of climate effects, but also interaction between climate and fishing and fishery management measures. And finally, the last example I'm really going to go into relates to phonology. So we talked about temperature phonology in terms of changing seasonality and how it feels like summer is expanding and getting longer. But we're also seeing changes in the timing of a number of other life history events for many species in the ecosystem, from phytoplankton all the way up to fish, birds, and some of our fisheries as well. So we see bloom timing of phytoplankton shifting in the spring and fall, changes in when we see the peak of zooplankton blooms and populations. We're seeing changes that percolate through some of our diadromous species, which are those that migrate from the ocean into rivers. And so spawning runs of those species, they move into the rivers to spawn. And the spawning runs of many of those species have started becoming earlier in the year. Puffins is one example of a bird species where we see their sort of spawning cycle and hatching dates and times of brooding their nest expanding out or shifting during the summer. And so there are lots of examples of changing phonology in the marine ecosystem. We typically think about this as sort of leaf out times or flowering times for terrestrial ecosystems, but we also see analogous experiences occurring in the Gulf of Maine. So this kind of gives you a sense of what has happened that we have observed already, but I also want to give you a sense of what we anticipate is coming in the future. So our temperature projections, we obtain these from an ensemble of climate models that, we take about 30 models together to try to understand what they each say about temperatures that we expect in the region. Looking out, this figure shows to mid-century. So in the Northeast Shelf region, which this line, the Northeast Shelf is shown in a black line here that I'm pretty sure you can only barely see in certain spots. But generally, this is the Northeast Shelf, Gulf of Maine, and Southern New England all put together. And we see that in the fall, we expect a stronger increase in temperatures to occur than in the spring. And overall, we expect warming of about 1.5 degrees Celsius by mid-century and 3 degrees Celsius by end of century under what is sort of a business as usual climate scenario. So assuming our carbon emissions continue along the trajectory that they have been on, these are the associated temperature changes that we would project for the future. And certainly that's just one carbon scenario, and our sort of climate policy choices will determine which path we actually are on. And as we look at this played out over the global ocean, I showed you this figure earlier for the observed temperatures and how warm the Northwest Atlantic region and Arctic has been. And as we project these out into the future, we see that the Northeast Shelf continues to be one of the regions that just really pops out as expecting strong levels of warming moving into mid-century and later century. So we try to understand what these changes might mean for species in a variety of different ways. One of the approaches that we can use are sort of qualitative expert-guided assessments of vulnerability of different species. And in these assessments, we can think about multiple ways in which the climate and physical system might change. So including temperature, which I've focused on in my earlier comments, but also changes in acidification, the variability of temperature, sea level, can bring multiple considerations to bear on assessments like this, and think through some of the biological traits of species to try to anticipate how those species will be affected by the climate changes that are expected in the region. And what we see here for a vulnerability assessment that was conducted for fish and marine invertebrates for the Northeast Shelf region is that regardless of species, we expect their exposure to future climate conditions to be very strong, essentially, to be in the high or very high categories of this assessment. But the biological sensitivity of the species varies quite a bit. So we have some species that we expect will be very vulnerable to the suite of conditions that are projected for the future. These include 3 shellfish, and those effects are largely coming through because of acidification and how it's expected to affect bivalves in particular, and then Atlantic salmon, which is already an endangered species and has been very affected by changes in the ocean ecosystem. I'm going to break this out a little bit further and have them organized by changes that we expect, whether positive, neutral, or negative effects on different species, with the species grouped in these plots by those that are traditionally found more in the mid-Atlantic. So these are species that would be managed by the Mid-Atlantic Fishery Management Council, and those species that are traditionally associated with New England. So here, what you see is that there are some mid-Atlantic species that we expect to sort of see positive benefits from the projected climate changes in the region. These include things like black sea bass, a couple of species of squid and stuck, which are small pelagic species, and then some negative effects on things like Atlantic mackerel and a couple of different shellfish. In New England, in contrast, we mostly see negative effects across the board on a variety of different species. Many of these are part of our brownfish complex, which is fish as a group of species that are related mostly to cod and flounders. So cod, haddock, a variety of different flounders, and we expect those to be negatively affected by the changes that we anticipate in the future. A lot of that is because many of them are already at the southern extent of their range, so what they're expected to see population declines, and many of them may not have the scope to sort of shift their range to track changes in the ecosystem. So we also project spatial distributions into the future, and we can do this by considering the environmental conditions under which we find species now, trying to understand the relationships between occurrence or abundance of a species to those environmental conditions. And then we can use the environmental conditions to drive the models forward. So if we change those conditions in the future, how do we expect the species distribution to change in terms of where it's found and how abundant it is? So this just gives you one example for lobster, and this is for the fall season. And essentially what we can do is model where they occur now for a period of time where we have observed them and evaluate our models based on those observations, then project that to the future by changing temperatures and having the temperatures be associated with where we expect them to find suitable habitat in the future, and then look at the difference in those maps and essentially see how things change. So in this figure, the purples and blues indicate declines, and the pinks and reds will indicate increases. So we are showing in this figure that we expect the distribution, we expect lobster to become less prevalent in the southern Gulf of Maine, on Georgia's Bank, and down into the mid-Atlantic, and more prevalent around mid-coast Maine into down east Maine and into the Bay of Fundy. So we can do this across many different species. We have these models developed for about 55 species. And just some other interesting changes are that we expect the Gulf of Maine to become more favorable for longfin squid, and also the coastal waters to become more suitable for black sea bass. So these indicate some of the species that we anticipate moving into this region as we move forward. And finally, we can use population models to understand changes in individual species. These are much more sophisticated models that account for biological mechanisms and potential environmental factors that influence rates of growth, rates of mortality, those types of rates of recruitment. So how quickly they can reproduce and how well juveniles might survive through the population. So we can use these models again to change the suite of environmental conditions that we expect in the future and understand how the population might be affected. And here I again show the contrast in the Gulf of Maine and southern New England lobster populations. So as we project forward from present, under 3 different temperature conditions, or warming of between 1 degree Celsius and 1.75 degrees Celsius out to mid-century, we expect a modest decline in the Gulf of Maine lobster stock and some potential for recovery actually from the current very low levels of the southern New England population, certainly not taking it back up to the historic highs. And in the Gulf of Maine, also not taking it down to the historic lows. So just to kind of summarize the key points that I hope I have tried to convey during today's talk, we do expect a variety of physical changes in the Gulf of Maine and Northeast Shelf ecosystem. The ones I have focused on today relate to temperature. So I've discussed the strong warming trend we're experiencing, the shifts in timing of warming and cooling, changes in seasonality and what that means for what feels like summer, and more frequent heat waves or high temperature events that we're experiencing in this region. There are also a variety of other factors that come into play with climate change that I haven't talked about, but certainly I think most people are familiar with sea level rise, changes in precipitation, which have implications for the ocean as well, not just for our rivers, but changing flow regime along the coast and in the rivers for species like salmon and alewives that move into rivers for a portion of their life. And changes in precipitation can affect temperature, salinity in our estuaries and along the coast as well. Also ocean acidification and multiple forces that affect primary productivity or phytoplankton growth are important to consider that I haven't touched on today. And then I've tried to tie this to some of the impacts that we expect in fish and invertebrate populations, from shifting distributions to changes in population productivity, and also changes in phonology, or the timing of certain life history events that they experience. And I just want to take just a moment to extend this a little bit further. I've focused a lot on individual changes, but certainly thinking about changes as they occur together, they are not occurring in isolation. So I've talked a bit about changes that we have seen and expect to see in the future. With lobster, I've also told you that black sea bass are moving into the Gulf of Maine from the mid-Atlantic. And so this will change interactions between those species, as well as possibly their interactions with other species. But our education program at GMRI would bring in fifth graders for hands-on interactive science learning programs. And our current program is really structured around this change in black sea bass and lobster, and what that might mean for sort of interactions between species in the future. So students look at things like, what do black sea bass eat? And sometimes they eat lobsters. So what does it mean that there are more black sea bass? What might the implications be for the lobster population? And do a variety of exercises to help them dig deeper into questions that they want to explore through the activities. And then certainly the implications are important for our fisheries as well. So historically, we've already seen in Maine a real shift from heavy dependence on our groundfish fishery to now heavy dependence on the lobster fishery. And I think, you know, there will still be a lobster fishery in Maine moving forward, but there may also be a potential for decline, but also many other species coming in that could provide new opportunities. So I think the real question is, what might fisheries of the future look like? And these may provide, you know, exploring questions along this line of change in fisheries, how that's connected to ecosystem change, and what, you know, future change or future opportunities could be available in Maine. I think has, you know, potential connections to how we think about and lessons that might be drawn related to history or economics, and particularly culture here in the region, where in our coastal communities, fisheries are such a part of the way of life and culture. And I think that's a really special characteristic here in Maine. So with that, I am going to wrap up. I'd be happy to take any questions or to explore any of these topics further. So thank you. I'm gonna stop sharing so I can see people. But you do have my email and phone number if you want to follow up.
Thank you so much, Dr. Mills. I do want to encourage folks to just simply unmute yourself and feel free to ask questions at this point in time.
I'll unmute myself. Thank you, Kathy. That was a great presentation and overview. I have a couple questions, just curiosity questions. Number one, what was the most valuable fishery before 2014? And then number two, you talked about the stratification and the warming, increased stratification with warming. Is that because there's cooling as well, deeper, as well as warming higher up, or is that just the differential rate of warming?
Good question. So I'll start with stratification. We are warming in the bottom waters as well. And so it is sort of consistent warming across the water column, but because it is, you know, just the general warming, they are not necessarily warming at the same rate. So there is some warming, but there is potential for greater stratification, and also salinity figures into that as well. And so some potential for salinity change to be altering the strength of stratification too. So it's really the sort of interaction between salinity and temperature. And then the most valuable fishery before 2014, it oscillated for a few years between sea scallops and lobster. So we're really, you know, fortunate here in the Northeast that we have two really valuable fisheries. And brown shrimp in the Gulf is another fishery that pops into the, you know, top category sometimes. And certainly prior to 2014, you know, it bounced around in there with scallops for a number of years.
Okay. Okay, great. Thanks again.
Mm-hmm. Thank you.
Hi, this is Debbie Landry, and thank you so much for your informative talk. Um, I'm a science curriculum developer, and so not only did I do science at one time, but now I'm trying to pass it along to young people. And one of the things that we've been trying to work with kids on is graphing changes over time. And so the data that you're using from the landings of lobster, for example, is a separate number than you're getting for the actual population of lobster. And I wondered, how do you make how do you quantitate lobster? Is it done, once a year, a couple times a year? Like how does that done? Because this is what has hindered me from allowing kids to graph lobster, because you can't use just landings as your basis.
Yeah, so we get numbers for most of our fish populations from what's called a stock assessment. And so this doesn't always happen every year for every species. Typically, they may do sort of quick update stock assessments from year to year. Most of sort of the in-depth look at a stock happens on a 3 to 5 year cycle. And essentially what a stock assessment does is it brings together the data that we have from surveys, so just scientific surveys on the water that can take a variety of different forms. For lobster, we have, federal and state trawl surveys, we have trap surveys, we have fishermen that are helping conduct surveys, and it brings in data from the fishery as well. So not only, sort of structured looks at the ocean and where lobsters might be and how many might be there, but understanding, a subsample of where people are fishing and how much they're catching in different places. So a stock assessment is a very extensive process that brings this all together. And like I said, they really sort of do a deep dive on the model on more of a 3 to 5 year cycle. And then on an annual cycle, bring in the information that is available to update them, but sort of stick with the same model that they've been using in the past and just add data to it. And so what I use usually, unless we're digging deep in terms of creating our own models for a particular research purpose, is when I want to sort of show changes in fish stocks or lobster stocks, any species, is I'll go grab the outputs from the most recent stock assessment. But that may not be the most current year because of the cycle of how they get looked at and timeframes for updating those.
Is that
helpful? But then again,
is there
our landing data often,
pardon me?
They are public. They are public, but they may be a bit harder to find. I mean, I think if you have a particular question or a particular species you want to look at, I'd be happy to walk you through like where you would look and how to find it for that particular species, which might then help you, find it for other species. Sometimes they're held at the management bodies and available through their websites, and sometimes they are more easily available through the Science Center, so sort of held within the science office.
Thank you. I will probably be in touch.
Yeah, it's definitely like if you know where to look, it's not hard. But
Right.
even within the stock assessment, you have to know what to look at because there are hundreds of tables often. And so I'd be happy to walk you through one or two species, and then that might give you a sense, or maybe that gives you what you need.
Okay, wonderful. Thank you.
Mm-hmm.
I don't want to cut in on somebody else who's waiting to ask a question, but I had a couple things. When we were looking at the phenology slides, the zooplankton seemed to be blooming for a much longer period, and it started blooming before the phytoplankton. So what's the mechanism at work there?
I don't remember exactly what that was looking at. So I guess I probably can't speak to mechanism, but I could speculate that it's probably more a reflection of sort of observations from a variety of surveys in the ecosystem. And so it could be a reflection of local differences that you may have, you may not have really started seeing the phytoplankton bloom yet, but you may start seeing, a bloom in a certain area, and then the zooplankton that come in at that time. And I would have to trace back all the original studies in that synthesized table to figure out like, where did they come from and what might that mean? But it's a good question. And so I think is, one of the bigger issues that raises though, is the potential for things that typically align to no longer align as you see these changes in phonology, especially. This has long been a discussion in the fisheries world where we talk about match and mismatch between prey and their predators. And, if the predator cycle doesn't stay aligned with the prey cycle, there's potential for obviously things to change quickly and dramatically there. And so it extends to zooplankton and phytoplankton as well.
And the kelp fishermen have been getting some good press lately. And certainly that's a strong carbon sink. But I'm thinking that to make a significant impact, it would take a phenomenal amount of kelp farmers out there to make any kind of a significant change.
Yes, I don't think that's been really well quantified yet, or I haven't seen actual calculations sort of thinking about how much carbon per area and how much area you would need, and what is that analogous to, like how much can you offset in kelp versus solar panels on a shoreside facility. I haven't seen that type of work emerge yet, but it might be out there and I'm just not totally informed. But I think that's a great question. I mean, I certainly think there are a lot of innovative new ideas coming forward, and it'll be interesting to see how we start sort of evaluating how they may all play out and contribute in different ways. And so I think also thinking about some of the, we've seen a lot of growth in aquaculture in general in Maine, which is exciting because it's opening up new opportunities and new avenues for coastal activities. But it also means that there's sort of an interaction around space for particularly fisheries like lobster that fish fix here that need bottom, to fish on. And so I think it's going to become increasingly important, and you're going to increasingly see more studies and more discussion around these issues of, cost benefit, and cost not just being economic cost and benefit not just being economic benefit, but broadly defined.
Any other questions for Dr. Mills?
Thank you for all being an attentive audience.
From the Department of Education, I can't thank you enough, Dr. Kathy Mills. It was a phenomenal presentation, and we appreciate it certainly, and know that quite a few more educators will tune in to the recording to catch the excellent presentation, outstanding information that you shared with us. So thank you so much.
Well, thank you for having me, and I'm really excited that there's interest in getting, more of this type of information into classrooms. And, in addition to being a scientist, I'm also a mother, so I really appreciate the folks who are helping educate the next generation and bring this information into understandable forms for them, because what I just said may not at all be understandable to them. My 11-year-old often tells me that. So thank you all for whatever you might do with this as the next step.
At this point, I'm going to stop the recording and open it up for just that, to discuss how, if there are ideas in terms of how this could best be shared.